Hello student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in previous lecture we have seen some problems on a residue. Then also we have seen one example on a integral which having the trigonometric function. Okay, that means we have seen evaluation of the integral having trigonometric function. Okay, so we have seen one problem on this topic. Now we will see another problems on the evaluation of the integral having trigonometric function. Okay, so second problem is show that for a greater than 1, integral 0 to pi d theta upon a plus cos theta equal to pi upon under root a square minus 1, and hence also find the value of integral 0 to pi d theta upon a plus cos theta bracket square. Okay, so this is the second example on this topic. Now we will see the solution of this problem. Okay, so if you observe here, the term a plus cos theta is a even term. Okay, we know that the cos theta is a even term. So therefore by using formula 0 to pi d theta a plus cos theta equal to 1 upon 2 0 to 2 pi d theta a plus cos theta. Okay, so this is equation number 1. So by using even function formula. Okay, so even function formula is defined as if the integral lies between 0 to a dx, then this can be written as 1 upon 2 0 to 2 pi dx. Okay, so here let us we consider the term 0 to 2 pi d theta a plus cos theta. Let us we consider this term. Okay, we will solve this term. Okay, so this term can be written in this way. So here we will put z equal to e raised to power I theta, z equal to e raised to power I theta. But we know that cos theta is e raised to power I theta plus e raised to power minus I theta divided by 2. Okay, so therefore e raised to power I theta means z plus 1 upon z we can write divided by 2. The solution of this is that is z square plus 1 upon 2z. Okay, so differentiate with respect to theta. Okay, so therefore d theta equal to dz upon derivative of this term. Okay, derivative of this term, or we can write dz upon e raised to power I theta into I theta. Okay, so we can write, okay, that is dz upon iz, dz equal to upon iz, the derivative with respect to theta. Okay, derivative of this term. So differentiate with respect to theta means e raised to power I theta into I theta. बरोबर. So therefore after solving we will get dz upon iz. Now we will put all these values in this integral. So therefore this integral will becomes 0 to 2 pi d theta a plus cos theta equal to, okay, so integral will becomes over the curve gamma. Okay, so dz means d theta upon iz, dz upon iz divided by a plus cos theta. Cos theta means z square plus 1 upon twice z. Okay, so here gamma is a unit circle which is denoted by z equal to e raised to power I theta. Okay, here the integral will change in the form of gamma, where gamma is z equal to e raised to power theta, which represent a unit circle. Okay, so therefore integral over curve gamma dz upon iz. So this can be written as calculation of this term, that is twice z upon z square plus 2za plus 1. Okay, so here 2 and upon I is a constant term, so take outside of this integral. So then in integral over curve gamma, so multiply z to this term. Okay. Okay, here z and this z will get cancelled. Okay, this z and this get will cancel. So only remaining term is dz upon z square plus 2za plus 1. Okay, now we will solve. Now we will solve this integral. Okay, so let us we take this term. We will find out the factor of this term. So now the factor of this term is z square plus 2za plus a. By using this formula, by general formula, we can find out the factor of this term. The factor of this term is given as z plus a minus under root a square minus 1, or we can say that z minus a plus under root a square minus 1, and second factor is z minus a minus under root a square minus 1. Okay, so these are the factors of this term. Okay, so therefore by using residual formula, integral or gamma f of z dz equal to 2 pi I summation I equal to 1 to n, residue of f at a point ai, index of closed curve gamma at point ai. Okay, so from this equation, which equation? 2 upon I, where 2 upon I. So 2 upon I dz upon z square plus a equal to 2 upon I 2 pi I, and residue of this term, residue of first term, that is minus a plus under root a square plus minus 1, index of closed curve at this point plus residue of second point, index of closed curve at second point. Okay, so here minus a minus under root a square minus 1, this point which lies outside of the integral, and this therefore the index of closed curve for this point will be the 0. Okay, so therefore now consider residue of minus a plus under root a square minus 1, g of z. Okay, let us consider g of z. So 1 upon z minus under root a square minus 1. So therefore g of z equal to, putting these values, so 1 upon z equal to, put z equal to this term. So after solving, so you will get, so this minus a plus a get cancelled. So 1 upon 2 times under root a square minus 1. Okay, so therefore residue of f at a minus a plus under root a square minus 1 is 1 upon 2 under root a square minus 1. Okay, so therefore putting these values in this equation, we will get left hand side is 2 upon I integral over curve gamma dz upon z square plus 2az plus 1 equal to 4 pi, in first bracket 1 upon 2 or under root a square minus 1 into 1. Okay, index of closed curve is 1, that is, and plus 0, index of closed curve is 0. Okay, so solving we will get 2 pi upon under root a square minus 1. Okay, so therefore this can be written as integral 0 to 2 pi d theta a plus cos theta equal to 2 pi under root a square minus 1. Okay, and this is nothing but, that is 0 to pi d theta equal to a plus cos theta equal to 1 upon 2 0 to 2 pi d theta a plus cos theta, and this is nothing but putting the values of this term, Okay, so we will get pi upon under root a square minus 1. Okay, hence the result is proved. Okay, now we will find out the value of integral 0 to pi d theta upon a plus cos theta. Okay, we know that a plus cos theta bracket square. We know that we have already proved integral 0 to pi d theta a plus cos theta equal to pi upon under root a square minus 1. Now differentiate with respect to a. So del upon partial differentiation, del upon del a integral 0 to pi d theta upon a plus cos theta equal to del upon del a pi upon under root a square minus a. Okay. So here 1 upon a plus cos theta, which is a continuous function. So therefore by using Leibniz rule, so this derivative can be taken inside the integral by using Leibniz rule. So 0 to pi del upon del a d theta a plus cos theta we can write del upon del a pi upon under root a square minus 1. Okay. So therefore by using formula integral 0 to 2 pi minus 1 upon a plus cos theta bracket square and into derivative of this term, that is 1 d theta as it is. Derivative of this term, so derivative of this term can be written as pi is a constant term. So minus 1 upon 2 under root a square minus 1, okay, into derivative of this term, that is twice a. Okay. So after solving this term, after calculating, so we will get integral 0 to pi d theta minus minus multiply. So a plus cos theta bracket square a plus cos theta bracket square equal to minus pi a upon a square minus 1 power 3 by 2. Okay. So this is the value of the integral 0 to pi d theta upon a plus cos theta bracket square. Okay. Now we will see the example number third. What is the example number third? So here evaluate integral 0 to pi d theta upon 4 plus sine square theta. Okay, now we will see the solution of this term. We know that formula, that is sine square theta equal to 1 minus cos 2 theta upon 2. We will replace instead of sine square theta. So this equation can be written as 0 to pi d theta upon 4 plus sine square theta equal to 0 to pi d theta 4 plus. So replace sine square, that is 1 minus cos 2 theta divided by 2. Okay. So which implies multiplying, cross multiplication and solving. So we will get 2 will transfer to numerator. So this can be equal to 2 integral 0 to pi d theta 9 minus cos 2 theta. Okay. Now we will put here 2 theta means that is theta, or we can say that psi. Okay. So differentiate with respect to theta. So 2 times d theta equal to d theta, or we can say d phi, d phi. Okay. Okay. So d theta equal to d phi by 2 we can write. Okay. So here a limit will be changed. If theta is 0, then psi will be 0. Okay. If theta equal to pi, psi will be 2 pi. Okay. So this is a psi. This is a psi. So putting these values in above integral, we will get integral 0 to pi d theta upon 4 plus sine square theta equal to 2 times 0 to 2 pi d psi by 2 upon minus 9 minus sine psi. Okay. So this can be written as 2 will get cancelled, 0 to 2 pi d psi upon 9 minus cos psi. Let us reconsider equation number 1. Now we will solve this in equation number 1 by Isel method. Okay. So here we know that cos psi is e raised to power I psi plus e raised to power minus I psi divided by 2. So let us put z equal to e raised to power I psi. So dz is I e raised to power I psi d psi. So therefore dz is d psi is dz upon I z. Okay. So putting these values in this cos psi, so cos psi will become z square plus 1 upon tie z. Okay. So putting all these values, all the values in this equation number 1, then equation number 1 become integral 0 to pi d theta upon 4 plus sine square theta equal to integral or gamma integral dz upon iz upon 9 minus z square plus 1 upon twice z. So where gamma is a unit circle, okay, which transfer along the z axis. Okay. So here we can take minus 2 upon I minus after solving this we will get this step integral over dz upon iz, and this is twice z upon minus z square plus 18z minus 1. Okay. So here z and this z will cancel. So minus 2 upon I is a constant term. Integral over gamma dz upon z square minus 18z plus 1, equation number 2. Okay. Now we will find out the factor of this term. The factor of this term can be obtained by using this method, and the factor of this term is 9 plus minus 4 under root 5. Okay, so these are the factors. Okay, so these are the poles. So z minus 9 plus 4 under root 5, z minus 9 minus 4 under root 5. So therefore, by using residual formula, integral over core gamma f of z dz equal to 2 pi I summation I equal to 1 to n residue of f at a point ai, index of plus core gamma at point ai. Okay, so here is a1 and this is a2. So now we will multiplying on both sides 2i. So 2i upon left hand side as it is minus 2i. So 2 pi I residue of f at a point, first point, that is this point, 9 plus 4 under root 5, index of closed core 9 plus 4 under root 5, residue at point this, that is f 9 minus 4 under root 5, index of closed core 9 minus 4 under root 5. Okay. Now we will find out the index of closed core. The index of closed core for this term 9 plus 4 under root 5. So this will lie outside of the unit circle and the value of this is 0. Second, index of closed core at a point 9 minus 4 under root 5. This point will lie inside the circle. So therefore the value of this is 1. Okay, now we will find out the residue of f at point 9 minus 4 under root 5. Okay, so let us we consider g of z. Okay, so 1 upon this is z minus a. Okay, g of z equal to 1 upon g of z, z minus a. So that is, put the value of z, that is 9 minus 400. So this minus 9 plus 9 will get cancelled, minus 1 upon 8 upon under root 5. So therefore residue of this term is minus 1 upon under root 8, 1 upon minus 1 upon 8 under root 5. Okay. So putting these values in equation number 3, we will get 2 upon I integral over core gamma dz upon z square minus 18z plus 1 equal to minus 4 pi. Index of closed core first term is 0 and second term will be 1, and residue of this term is, that is minus 1 upon 8 under root 5. Okay, so putting solving this, we will get pi upon 2 under root 5. Okay, so therefore from equation number 1 and 2, we will get integral 0 to pi d theta upon 4 plus sin square theta equal to pi upon 2 under root 5. Okay, so these are the 3 examples on integrals which contains the trigonometric function. Okay, so dear student, here we have completed the second method of the residue. Okay, so I will give you some example number 4 and number 5. So you have to solve this example as a homework. Show that integral 0 to pi d theta upon 9 minus cos square theta equal to pi upon 6 under root 2. And second example is 0 to 2 pi d theta upon 3 minus 2 cos theta plus sin theta equal to pi. Okay, so these are the two examples for the homework.